Hey guys, today we're talking about isolating the variable. This is a skill that we need in order to take the next step in solving systems of linear equations. That next step is when we go to substituting, solving systems of equations by substitution, and that's what our topic tomorrow is going to be. So today we have to isolate the variable, and we've talked a little bit about this before, but we're going to look at some more complicated examples. The date you should have on this page is January 22nd, 2014. Make sure you're numbering all the pages in that packet of guided notes that I gave you. I think that this one is page 3. If I'm wrong, though, I'll let you know in class tomorrow. So our objective, I can isolate variables in a variety of different equations using the rules of algebra. A little reminder, if you guys didn't know it already, to isolate something is to make something be alone. So if you want to isolate your sister from you and your friends when you're having a sleepover, you tell mom, get my sister out of my face because she's bugging us. You're isolating her. You're making her be alone. And it's really mean, so don't do that. All right, so let's jump right in. The steps that we need to do in order to isolate the variable are a little bit confusing when they're just written in sentences, but as we work through some examples, they'll make a little bit more sense. First, you have to identify the variable that you're isolating. You might end up with an equation that's like 3pq minus 2rm equals m squared nr over p. If you don't know which of these variables you are supposed to be isolating, it's going to be almost impossible for you to actually solve the problem. So we are going to identify the variable, and I require that you circle the variable you are isolating. Then you are going to undo the things that happen to the variable using SADMAP. If this sounds familiar, it should. It's the exact same thing we do if we have, let's say, for example, this two-step equation, where I'm going to find my variable, I'm isolating my variable, and then I undo the things that are happening to it using that upside down T until I get my variable completely alone. Okay, so you know how this process continues. And we've done this before, but now we're going to be dealing with things that have way more variables than you're used to. Finally, you're just going to continue through SADMAP until the variable is all alone, all by itself. Let's look at some examples. This is a very basic example, very, very simple, just one step to solve this. Let's say the problem tells me to solve for m, all right? First thing to do is find the variable you are looking to isolate. In this case, it is m. Next, I'm going to use SADMAP. I should see SADMAP written all over your papers, all over your test when it comes to this situation. You have to use SADMAP. To get m alone, we have to undo what's happening to m. Remember that a fraction bar means divide. All of these notes are things you should be writing in your notes. In order to undo this division, we have to multiply. So what are we going to multiply? We're just going to multiply by v. This thing here that is doing the dividing. So I multiply that side by v, I multiply that side by v, and my v here and my v here cancel, leaving me m equals d times v, and I have now isolated my variable. Okay, a very basic example for you. Let's go ahead and try another one. This one, as you can see, is quite a bit more complex. In this case, we are going to solve for t. Don't forget about SADMAP, guys. Okay, so I need to first circle the variable that I'm working with. Hang on, let me make this a little bigger to make our lives easier. All right, that's what I meant to do. Okay, so we have d equals 1/2 times a times t squared. The variable that I'm looking to solve for is t. and I need to get it completely by itself. So let's take a look at SADMEP. First thing I undo is subtraction and addition. I don't have any subtraction or addition here to do, so those are taken care of. Next, I take care of division and multiplication. Don't get confused here. Take it step by step. I am going to say to myself that I want to cancel this fraction here first, because that fraction is making my brain explode. 1/2 is multiplying by a and t and the t squared. So to get rid of that, this multiplication that's happening here, I have to divide by 1/2. Divide both sides by 1/2. What I end up with then is d divided by 1/2 equals a t squared. This 1/2 and this 1/2 cancel. You might be saying to me, Mrs. Ott, this looks insane, and I have no idea how to do that. Let's try and simplify this. I'm going to put this over here on the side to show you. If I have d over 1/2, what I really have is this d is not just a plain old d, it's d over 1. Okay, any number or any variable for that matter can be put over 1 and it doesn't change its value. This fraction bar is division. Okay, that means divide. So I'm really doing d over 1 divided by 1/2. When you divide fractions, you leave the first fraction, multiply, and flip the second fraction. That is going to give you d times 2 is 2d, 1 times 1 is 1, which gives me lovely plain old 2d. 2d equals a t squared. I've simplified this now. If that confused you, please go back and watch it again. Do not just assume that you know what to do. It is really important that you guys understand this whole dividing by fractions thing. Very important. All right, so I'm still not done yet. I still need to get t all by itself, and I still haven't finished all of my division and multiplication. I've got this a here. A is multiplying by t squared, so I have to divide by a, divide by a. That gives me over here 2d over a equals t squared. Unfortunately, I can't make this any more simple. That's as simple as it's going to get. Sorry, guys. I am still not done, though. Notice that t still has an exponent. I have finished my division and multiplication, but now I have to cancel out my exponents. In order to cancel out this square, this t squared, you might remember this from a long time ago, all I have to do is take the square root. I'll do that in a different color so it's a little bit easier to see the square root. A square root is going to cancel the squared and end up leaving me with just plain old t. I can't do it just to one side, though. I have to do it to the other. So my final answer is going to be t equals the square root of 2d over a. How's that for a complicated one, guys? All right. Just take it step by step, following SADMEP the entire way. All right, I think I might have time for one more example. I'm going to do this really quick. This is, once again, using SADMEP. I am going to solve for n. I'll use my upside down t. I am going to say that I have no subtraction or addition. Get rid of those. Now I do division and multiplication. I will get rid of this divided by p by multiplying both sides by p, which gives me mp on the left-hand side. This number 3 is just example 3, equals, my p and my p cancel, leaving me 6n squared. I'm not done with my division and multiplication. I have to cancel this 6, so I'm going to divide by 6, leaving me mp over 6 equals n squared. I'm done with my division and multiplication, so now I just have exponents. I'll do it in a different color to make it easier to see. In order to cancel my n squared, I take the square root of both sides of the equation, giving me n equals the square root of mp over 6. Okay? Rewatch those if you need to. Really try and make sure that you understand this concept. We'll do practice tomorrow, but it's really going to benefit you if you really have a good grasp on it. Your reflection question here is solve for x. Do not forget to use SADMEP, guys. This one, just be careful. Use SADMEP and you'll be okay. All right? Have a great night. I will see you tomorrow.